All right, guys, now we're going to look at quadratic functions and models. Quadratics. Let's get going. Quadratic. What is a quadratic? A quadratic is a polynomial of degree 2, which means your exponent is 2, your biggest exponent is 2. And it usually looks like this. This is called standard form. Well, it's quadratic form of a function, not standard form. Some books do call it standard form. Your book is going to call that quadratic form, which is completely okay. Standard form, now they're calling it standard form, looks like this right here, where you have a times x minus h squared plus k. And what that form is, you can tell the vertex. When you graph a quadratic, you get a parabola. And you can tell the vertex by looking at that equation. That's why it's called standard form. You can get there by completing the square, which we're going to do a lot today and tomorrow. The vertex, by the way, is the h and k. So when you look at standard form up here, the vertex is that h, the opposite of what's inside the parentheses, and the k, which is exactly what's outside. The parabola may open up or open down. That depends on the a. If a is positive, look where the a is. The a is in front of your parentheses. If it's positive, it's going to go up. If a is negative, it's going to go down. All right, it says express this one in standard form and sketch the graph. So here's how we're going to roll. Here's how we're going to express these in standard form. First of all, we're going to take the 2, whatever number's in the a, we're going to factor it out of the first 2 terms only. So I'm going to take the 2 out of the 2x squared and out of the 12x, and I'm going to leave the 23 alone sitting out here. I need to move this graph just a little bit out of the way. And then I'm going to complete the square. When I complete the square, I take half of 6, which is negative 3, square it. That gives me plus 9. Now, I put a plus 9 inside there. I can't just add a 9 there because I want to. And really, because there's a 2 in the front, I really just added 18. So what I'm going to do to keep the equation equal is I'm going to actually subtract the 18 from the same side because I want the f of x over here by itself. So now I can factor, and to be honest with you, whatever the half was that you took, that's where I put that negative 3 up there. That's what's going to go inside your parentheses. Also because 3 times 3 is 9, 3 plus 3 is 6, so it factors perfectly. And I get 5 out here, which tells me my vertex is 3, 5. Okay, so when I come over to my graph now, I'm going to go to 3, 5, which is right here. And because it is a positive 2, my graph's going to open up. Really and truly, I'm going to go right 1, up 2, right 1, left 2. That's what that 2 does in the front. It's actually a vertical stretch. We'll talk about more of that in class tomorrow. And there's all you got to do. All right, maximum or minimums. If a parabola opens up, it has a minimum, and the minimum occurs at the vertex. If it opens down, it has a maximum, and it occurs at the vertex. Now, the minimum or maximum value is the y-coordinate of the vertex. If they ask you what the value is, it's going to be the y-coordinate. Okay, you see right here, it's k. It's the k. It's the y-coordinate. So let's see if we can find a couple here. All right, it says consider that, express it in standard form, sketch the graph of it, and find the max or min. Okay, all that's really about the same. You got to do the same thing no matter what they ask you pretty much. But the first thing, every time we're going to put it in standard form. So I'm going to take out the 5 like I did a second ago. Out of the first 2 terms, leave some space, put the plus 49. Right, I'm going to complete the square. Half of 6 is 3. I'm going to square that and get 9. Now, be careful here. It looks like a 9. It's really 9 times the 5 in the front, which is 45. So out here I'm going to put a minus 45 to keep my equation equal. So I have 5 times x minus 3 squared inside. 49 minus 45 outside is 4. So my vertex is going to be 3, 4. All right, so I'm going to come over here. I'm going to graph that thing as it said express in standard form, which I did. That was the first part. Check. Sketch the graph. I'm about to do that. 3, 4 right there. It's a positive 5 in the front, so technically I would go right 1, up 5, 1, 2, 3, 4, 5. Left 1, up 5, like that. It would be a very skinny parabola because the bigger the number in the front, the more you vertically stretch it, the skinnier it gets. And then part C says, what's the maximum or minimum? Now this one has a minimum, so you need to label which one it is. It has a min. And remember, the minimum or maximum value is the y-coordinate of the vertex, so the minimum value is 4. The minimum of that parabola is at 4 right there. All right. Another way to find the max or min, remember, it always occurs at the vertex. There's another way to find the vertex besides putting one in standard form, and that is to do this right here, to do negative b over 2a. Whenever you work out negative b over 2a, that gives you the x-coordinate of the vertex. Now remember, the max or min is the y-coordinate. So after you find that x-coordinate, we're going to plug it back in and see what it says right there. You do f of negative b over 2a, f of negative b over 2a. which means you're going to plug whatever you get for x back in your equation or your function and see what you get for y. Remember, y is the value you want. Okay, a couple of them here. Find the maximum value of each quadratic. So the first one right here, I'm going to do negative b over 2a. Negative b would be negative 4. A is 1 there, so I'm doing 2 times 1. That gives me negative 2. Now, that's not the value. I got to take the negative 2 and plug it back in. So if I plug it in, I would get negative 2 squared plus 4 times negative 2. That's going to be 4. That's going to be negative 8. So that's the value. And because x squared is positive, that means it opens up, which means that's a min. So my minimum value is negative 4. That's the min. Let's try one more here. Second type, negative b over 2a. Negative b over 2a would be negative 4. That's always the b value. That's always your a. Over 2 times negative 2, which is 1. Now remember, 1's not it. You got to take the 1. You got to plug it back in. So I'm going to get negative 2 times 1 squared plus 4 times 1 minus 5. That would give me negative 2 plus 4 minus 5, which is going to be negative 3. Now that one opens down because the negative 2 is negative 2. So I'm going to put minimum. The minimum there, sorry, the max. I don't know what I'm saying. The max is negative 3 because it opens down. It has a max. Sorry about that. It's got a max. Let me write it again. That's a max, and that's the y coordinate. Remember, it's negative 3. One more slide. All right, now title today did say models, so we're going to do one model here. It says most cars get their best mileage when traveling at a relatively modest speed. Sad to say. The gas mileage M for a certain new car is modeled by this function. Notice it's quadratic, where S is speed and M is miles per gallon. Speed is miles per hour. What is the car's best gas mileage and what speed is it attained? First of all, you're looking for a max here. All right, what's the maximum speed and maximum miles per gallon that, what's the best for the car? Which means for a parabola, like because this is quadratic, because it's a parabola, you're looking for the vertex. That's what we're doing. We're still just looking for the vertex because that's where it happens. That's where the gas mileage is the best, at the height, because the gas mileage is in mileage. We know what is the maximum. Okay, notice notice the A is negative, which means it opens down, which means it does have a max. So I'm going to do what we've been doing. I'm going to do negative b over 2a here, which means I'm going to do negative 3 over 2 times negative 1/28. All right, which is kind of crazy. So I'm going to take a second and punch it in my calculator. I'm going to punch it in. I got 42. Now, that's good. Now, what that means to me is that's the x coordinate of my vertex, or in this case, the s coordinate, which means that's the maximum speed. And I know most of you go 42 miles per hour everywhere, but in this particular car, 42 miles per hour gives you the greatest mileage. Let's see what the mileage is. So to figure that out, I'm going to take that 42 and I'm going to plug it in for the s's, just like this. 3 times 42 minus 31, and see what I get. And that's going to be my maximum, my best miles per gallon. I'm going to punch that in now. I just got finished punching that in. And what I got is I got 32. So what's the car's best gas mileage? 32 miles per gallon. And what speed does that occur? At 42 miles per hour. So if you drive 42, you're going to get 32, which is the best you can do. Most people aren't going to drive 42 to get 32. Most people are going to drive 50 or 60 to get 26 or 28. That's just how it is. But if you want the best gas mileage, you got to find that perfect speed, and there it is. All right, hope that wasn't too bad. All quadratics, a lot of vertex problems. We'll work on it in class like we always do. See you tomorrow.